Assalamualaikum and hello everyone. We are from Group 7 who will be presenting about differentiation, maximum and minimum. Maximum and minimum value refer to the highest and lowest point of a function. This value occur at a stationary point, where the slope of the curve is zero. By using differentiation, we can understand how the function changes accurately and use to locate these points. This concept is very important in optimizing problems as it is commonly used in engineering and real-life situations. For example, we can use it to find the maximum efficiency or the minimum cost. The first derivative represents the slope of the curve. At the maximum or minimum point, the curve becomes horizontal, meaning the slope is zero. This point is called stationary point. To find the stationary point, we need to set the first derivative equal to 0, which means f prime x is equal to 0. After that, we use the second derivative test to determine whether the stationary point is a maximum or a minimum value. If the second derivative is less than 0, the point is a maximum point because the curve is concave down, like this. If the second derivative is greater than 0, the point is minimum because the curve is concave up.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Akilaman Sarah binti Muhammad Zakir and I would like to continue to present about methodology. There are few steps to find the maximum or minimum value of function fx. First is first derivative. Differentiate the function fx, which is to represent the slope of the curve. Second is critical point. Set f prime x equal to 0 and solve x. This value is called critical point where the curve is horizontal. Third step is second derivative. Differentiate the f prime x to get the f double prime x. Fourth step is the second derivative test. Substitute the critical point to f double prime x. And the last step is final value. Substitute the x value into the original function fx to find the maximum or minimum value. Next is practical solution. Let's see how we solve this problem. By using the method that I have explained, we will obtain the correct answer for the questions.
Hi everyone, today we are playing the role of lead engineers. Our mission: design a 30 cubic meter storage tank while using the least amount of metal possible. We are going to use calculus to save money and save the planet. To do this, we need two things: our constraint and our goal. Our constraint is the volume, which is pi multiplied by radius square multiplied with height. That has to equal exactly 30. Our goal is to minimize the surface area, that is the top circle, the bottom circle, and the side wall wrapping around. Mathematically, that is 2 pi r square plus 2 pi r h. The problem and the hack. Here is the catch. Our surface area formula has two variables, radius and height. That's a nightmare to solve, right? So, we use a substitution hack. We take our volume formula and rewrite it so height equals 30 divided by pi r square. Now, we plug that into our area formula. Suddenly, the height disappears. We are left with a clean, single variable function, which is area equals 2 pi r square plus 60 divided by r. Now, how do we find the sweet spot, the absolute minimum? We look for where the slope of the curve is 0. We take the derivative. The 2 pi r square becomes 4 pi r, and the 60 per r becomes negative 60 per r square. We set the whole thing to 0 and solve for r. After a little algebra, we find our perfect radius is approximately at 1.68 meters. But wait, did we find the minimum area or the maximum? We don't want the most expensive tank in history. We check the second derivative. It came out positive, which is in calculus means our graph is smiling or concave up. That confirms we are at the very bottom of the curve, the absolute minimum. Finally, we plug that 1.68 radius back in to find our height. it comes out to 3.37 meters. Check this out. The height is almost exactly double the radius. That means for any cylinder to be perfectly efficient, its height should equal its diameter. And there you have it, engineering perfection through the power of math.
To conclude, the key point of this topic is how differentiation help us analyze and optimize functions. We use differentiation to determine the maximum and minimum values of a function, and this allow us to determine the behavior of a system and identify the most optimal points. First, we use the first derivative, and it is crucial to help us find the stationary point. The stationary point is this point where the slope of the curve is at 0, and the function could reach a maximum, minimum, or a point of inflection. So to distinguish between these possibilities, we use the second derivative test, and this second derivative test tell us whether the stationary point is a maximum or at a minimum, and giving us a precise information about the function's behavior. And through the use of practical and engineering examples, we see the differentiation is an effective tool for solving optimization problems. And whether it is to maximize efficiency or minimizing cost or reducing material usage, this concept is widely used and applied across all engineering fields. So at the end, differentiation is not just a mathematical procedure. It is a fundamental technique that engineers use every day to achieve optimal result in design, production, and problem solving. That's all from my group.
Thanks for watching.